Our presentation is Learning Obstacles in the Capture the Flag Model. My name is Kevin Chung. I'm a student at NYU Polytechnic School of Engineering, and I'm also a product security intern at Etsy. I help manage the Information Systems and Internet Security Lab at NYU Poly, and I also help run our CTF, Seesaw CTF.
I'm Julian. I run the application security team in a large organization in New York. I teach and help out at NYU Poly. I help run Cybersecurity Week and ISIS with Kevin. And I also run Ghost in the Shell Code.
So I think the first question we want to address is, what is Capture the Flag? So CTF is a competition where teams try to solve security challenges for points, and the team with the most points at the end of the CTF is the winner. This is an example of what a CTF would look like to a competitor. So we see on the left blue boxes, which are each of the challenges and the points associated with each of them. And on the right are the categories for each CTF. So the goal for any team is to solve as many of these as possible and rack up as many points as they can. So CTFs are useful for mainly for two things: for the evaluation of skills and the teaching of skills. They are good for presenting scenarios that are unlikely to come up in academic situations, and ideally they'd be useful for. Ideally, the problems would be very practical and realistic scenarios. So, learning in CTFs is a process of self-education in which the competitor is going to be going through lots of struggle, lots of research, and then eventual breakthroughs in their methodology for solving the challenge. An important part of CTF is that through the entire process, they're receiving feedback through what they're doing, right? So when you try to solve a challenge, you'll know immediately whether it was right or wrong because you'll be able to get the points or not. That feedback loop is important for incremental improvements that will hopefully lead to eventual success, unlike other competitions. And it's important that during all games, and especially CTF, that competitors receive that kind of feedback loop, right? So, through organizing Seesaw CTF, we've identified these key problems in CTF, and they are a barrier to entry, lack of exposure, increasing difficulty, challenge point evaluation, challenge design, challenge implementation, and challenge infrastructure. So initially, one of the first problems is the barrier to entry. CTFs are hard. They're not pick up and play like games like checkers. And because of the wide knowledge base that's being covered, there's lots of high skill requirements, which makes it very difficult to play on your own. And a lot of the content that's covered in CTFs are not covered in standard education. So how many people do we expect to know what to do when we're provided this binary? And it presents us with this this text, right? Students they're either going to know what to do, they're going to figure out what to do, which is unlikely, or they're going to give up. And so after the barrier to entry, we have this lack of exposure that CTF is susceptible to. CTF is not as popular a game as like checkers or chess. And really, the introduction process typically becomes a process of someone who's on a CTF team or in the security industry saying, to get involved in the security industry, you should play CTFs, which is unlike something like chess or checkers, where everyone has really heard of it. So CTF time, a CTF team tracking site tracks only about 3,200 teams. And we can see that most of the teams come from the US, and really it's a really small game in comparison to something like it's really small compared to something like Major League Gaming, which tracks over 20 million teams. So since CTFs have been going on for a long time, there's been a pattern of increasing difficulty throughout CTF. So challenges are becoming harder and harder, and we're locking out newcomers or we're scaring them away. So An example is in CSAW 2011, we saw cryptography challenges that were simple substitution ciphers or simple encoding schemes, right? Now in CSAW 2013, our crypto challenges involve lots of complicated mathematics that could be very intimidating. As competitions grow, challenge developers, they're also learning and they're growing and they want to see more come out of their competition, so they naturally make them harder. This is blocking newcomers. So as a quick example, this was the first cryptography problem in CSAW 2011, and we can see that it's just base64 encoded text. We decode it and we see the key in plain text. No problem. In CSAW 2013, the problem was much more complicated. Competitors had to analyze custom cryptography, analyze the vulnerability, and then decrypt the provided text. So in a span of 2 years, we made a massive jump in the in the difficulty of the provided problem, which was the very first cryptography problem provided to students. So another important problem is how we evaluate the problem, how we assign point values to CTF problems. So the point value is the very first thing that competitors are going to see when they look at the challenge. They're going to look at the number and they're going to rate themselves about how can they solve this. And it can be very intimidating to new or really intermediate players. They see this number and they might get intimidated. Well, this is a really hard problem, or okay, this is a really easy problem. So even slight intimidation is going to be very discouraging. And you'll notice, or we've noticed that the higher rated a problem is, the less likely that a team will participate on it if they're not very confident in their abilities. So in order to avoid that, we try to have a single entity pick point values for challenges instead of having developers suggest their point values. So in addition to how we evaluate our challenges, it's important to design them properly. So challenges should be designed for load, obviously, since they're going to be hit by thousands of times throughout the competition. And when we're designing a challenge for education, we want to lead the competitor through the challenge, providing hints liberally, instead of confusing them away from the answer. One of the important aspects to note of CTF competitions is that we should avoid brute force components. This is important because lots of challenges try to involve brute force in some way to kind of make it more difficult for the competitor. And really, brute force components just become more of an annoyance given the time constraints that a CTF is usually involved in, time constraints that a CTF is usually conducted under. It becomes more of an annoyance than a real problem. You want to take this?
So it's also important to implement the challenge you've designed properly. We see a lot of times challenge developers decide that they design a really excellent challenge and they go and write it and it's full of buffer overflows that weren't intended. So QA is a huge part of making sure that your competition is going to be successful. Every time you get a challenge, you need to test it out, make sure it works. You want to be able to make sure that when the competition starts and you launch your challenge, that competitors can connect to it, that it can be solved in the intended way. And during the QA phase, you want to make sure that the challenge accurately reflects the assigned point value. So, yep.
And I think most importantly is we want to avoid releasing challenges without QA. We want to avoid any potential or unforeseen bugs that can come about when we don't QA our challenges. After the challenge itself, we also need to look at the challenge infrastructure. So all infrastructure should be double-checked. It's kind of obvious, but it seems to be overlooked in lots of the times. So primarily, we should be looking for issues involving denial of service, web vulnerabilities, or arbitrary point scoring. And these three problems, they seem like something that it's not really too common, but it's happened in lots of CTFs, including our own. And a lot easier to host infrastructure on EC2 or something external versus to hosting things internally for obvious reasons, I think. And it's important to know that downtime can and will happen. Seesaw CTF was down for about 30 minutes last year, and lots of CTFs have experienced that kind of problem. You should strive for around-the-clock maintenance, but just understand that your challenges are going to go down. Your CTF may or may not go down, or may or may not stay up the entire competition.
So all this work is based on a competition that Kevin and I run called Seesaw CTF. But the CTF is just a small portion of the entire event, which is called Cybersecurity Awareness Week. It's really an amazing event. It's student run almost entirely at NYU Poly. We have 6 different competitions, of which CTF is the largest, but we also have a high school forensics competition, an embedded systems competition, a research, policy, and quiz competition. We also have a huge cybersecurity career fair where organizations come from all over the country to poach all the finalists from these 6 competitions who are the best high school students, undergrads, and grad students in the United States. We also have a conference at this event, which this year is focused on security automation, and it's a great excuse to come to New York.
Okay, so in conclusion, we see that there is great potential in Capture the Flag. It has rising popularity, but it's still pretty unpopular compared to other kinds of games. It's also a pretty versatile platform. You can really use it to test lots more things in security, but it's most popular for security. But it's also important to note that although we push it like it's going to be like great for every competitor, it's not a guaranteed benefit to those who play in it. And it's difficult to play, and it's also difficult to organize. So thank you to all of our Seesaw judges and Usenix. And does anyone have any questions?
If you have a question, would you mind coming up to the mic so we can get it on the recording?
That was a formal workshop. Hi, this is Giovanni Vigna from UCSB. I don't know if this is really, first of all, Seesaw stuff is great. But I have a comment more than since it's a workshop, more than a question.
Yep.
I also have a question though. And the comment is, I think we should stop calling CTFs things that are not CTFs. I mean, challenge-based competition are not capture the flag competition. You can call the solution the flag, but it's not the flag. CTFs were started as, attack and defense, multi-team, capture the flag, like the game Capture the Flag. You're different teams, you're attacking the team is defending the flag, the guy capture the flag. These are great competition. They're called challenge-based security exercises. We could find another cool name. This would be a great venue to find a cool name. But I think it's confusing to people to call it CTFs. You don't capture, you solve a puzzle. You don't capture the flag of another team. So this is something that always, I found it confusing and, partially annoying. The thing that also I would like to understand is, what do you think is the best way to characterize and quantify the learning process that you see happening in this competition? So people come to you and, solve problems. Maybe you don't have it. I ran a competition and we tried and we failed miserably several times. But I think it would be good to hear from people that run competition. What do you do to understand the level, the gain that, from an educational point of view, the participants had by participating in this competition? What do you think is a good way to do it?
Well, I think we already try to quantify it through points, but you're right in that it's very difficult to determine exactly how much a competitor has gained out of it. But is there really ever truly a way of measuring that? Like, I mean, a student can take a class and receive an A, but have they really learned anything?
I agree. I mean, evaluating learning is difficult to assess, but for example, point-based situations can be limited to just the result. They don't take care of the process.
Right.
Usually take A in a class. interaction with the teacher actually tries to understand if you gain mastery of the subject. And I'm not saying that this has to happen. Capture the flag can be just fun and motivational, but I think that it would be an interesting discussion to have since this is sort of a workshop more than just a conference.
Absolutely.
Hi, I'm Jonathan from Carnegie Mellon. I wanted to ask a bit more about the increasing challenge difficulty phenomenon you observed, because I'm kind of curious about that. I wonder, is it at all motivated, is the fact that maybe there aren't that many really easy like crypto problems partially responsible? Because I imagine there's only so many times you want to ask like the Caesar cipher question or
Sure.
the substitution cipher question.
Right.
So how much is it like the fact that it's easier to make more interesting problems that are harder versus the fact that is it possible to come up with more creative, easier problems that aren't maybe the classic ones to potentially make it so we can bring the difficulty level down without compromising on what problems we've seen before?
Well, I think there's probably a way to do it more creatively, but I think it's important for introductory CTFs like Seesaw that we also try to include those kinds of basic problems in addition to the more harder problems. Clearly for something like Plaid, I think you guys aren't going to include like substitution ciphers, but when you expect to have newcomers, you should try to make your challenges a little easier, I think. Right?
Thanks.
Hi, this is Sam Weber from the Software Engineering Institute. So it's very frustrated that this workshop is at the same time as a cybersecurity experimentation and test, because after all, one of the purposes of Capture the Flag is supposed to evaluate team performance and individual performance. And to follow up on the previous comment, it didn't seem that in your paper you talked very much about how you evaluate whether person's or team's performance on this thing is actually reflective of how much they know or able to perform in a real cybersecurity setting. Do you have any comments or feelings about that? Or are people just getting skilled and doing an artificial sort of
I think we both have comments here, but I'm just going to echo what I said before. I think you can be tested and you can be evaluated lots of different times over and over again, but that doesn't really reflect how well you do, I guess in the real world, we'll say. There have been situations where I've received A's in classes and I don't understand the material like 2 days later, right? I don't think that, yes, points are really a really bad system of measuring students' competence, but I'm personally not sure of a better way to do it. And I guess Julian also has his own perspectives.
So I agree with everything Kevin said, but I also think that we do care that students are learning, and we sort of leave that process up to the challenge designers. We tell the challenge designers, we want you to create challenges that are insightful, that bring students through a technical process, and really well-designed challenges sort of force students to learn while they're solving them if they don't already know the material. So we try and design challenges where it's impossible to get from step 1 to step 2 without fully understanding a concept or a technology or a language or something like that. So it's hard to see with like just words, but I think if you look at some of the challenges, some of the write-ups, and most of our challenges are not ideal, but we do have a lot of them that fit this model of forcing students to learn through solving them.
Hi, Cynthia Irvin, Naval Postgraduate School. So it sounds like in your challenge design, you really have two kinds of design going on. One is to design the challenge to create this learning opportunity for the people who will be playing your game. But the other design challenge that you have, which I think you brought out, and I'm grateful that you did this, is that the designers themselves have not applied the full gamut, or even a good percentage of the gamut of security engineering techniques that could be applied in building something that is more robust against buffer overflows, denial of service attacks, etc. And so maybe your game has a teaching moment with respect to the design or the implementation of the overall design that your designers come up with. Your designers may be creative artists, for all I know, but then the people who go to implement it need to provide good software engineering practice to this. And so is this maybe tied to a course in security design principles or anything like that? Or could it be? So that then you'd have two teaching opportunities, one for the players of the game and second for the people who are building it.
Okay.
So traditionally we have a panel of industry experts who design these challenges, and they have full-time jobs or they have side projects and they're busy people, and so they're doing this for all in their volunteer time because they love CTF. So one of the major problems we run into is people forego all these security principles and good software design processes because they're just trying to ship their product and give it to us and work on something else. So that's certainly a problem. And we definitely don't have it linked into anything in the university, but I think the major problem is that we ask experts from the field to write our challenges and not students, and that's the problem. We expect the students to play in the competition, and we have the professionals write the challenges. I think that's our major problem.
Thanks, guys. We're